So for this first titration curve I'm going to create, I'm going to have a weak acid with a strong base. So acetic acid and hydroxide are going to react to produce acetate ions and water. Okay, so I'm going to draw my curve. On my y-axis I have pH. On my x-axis I have volume of my titrant, which in this case is hydroxide. Okay, and then I'm going to actually draw my curve. Okay, so it's going to look something like this. Okay, so let's identify a couple of key points. The first point is my equivalence point, where my number of moles of acid and base are the same. Remember, this is going to be different from your endpoint because your endpoint is simply where your indicator changes color. So if you're at it once you're at your endpoint, that doesn't necessarily mean you're at your equivalence point. It just means you're within the range of the indicator for it to change color. So let's say, for example, 20 mils is required to reach my equivalence point. Then to reach my half equivalence point, I would require 10 mils of hydroxide. Okay, so let's identify what's present at each of these key points. Okay, so in the very beginning, okay, I haven't added any of my strong base. So the only thing I have present is my weak acid. So I've got my acetic acid here. Okay, as I add hydroxide, what's happening is I am causing this reaction to occur. So the acetic acid will react with the hydroxide that's being added, okay, and it'll produce acetate and water. So at my half equivalence point, what I have is I've added half as much hydroxide as is needed to reach my equivalence point. Okay, so at your equivalence point, since you have equal amounts of acid and base, what's left over, the only thing that's present right at your equivalence point, is going to be the acetate ion. And that's why when you have a weak acid and strong base titration, when you have that reaction, that's why at your equivalence point, the pH is going to be basic because you have only acetate ion there, which means at my half equivalence point, since I have equal amounts of acetic acid and acetate, those are going to be the ions that are present. Okay, so as I add hydroxide, the acetic acid is reacting with hydroxide and it's forming the acetate ion. I don't have any hydroxide because all of it's going to react. As soon as I hit my equivalence point, the only thing that's going to be left over is my acetate ion, and water, but we're going to ignore water. As soon as I go past that, now I have acetate ions and I'm adding hydroxide. And so no more acetate's going to form. I'm just going to keep adding hydroxide. So what's going to be present from here on is going to be your acetate ions and hydroxide. So if you're asked a question like, for example, which of the following affects the pH, or what species that's present affects the pH the most, right at the beginning it's going to be your acetic acid. Okay? Then it's going to start being acetic acid and your acetate ions. Right at your equivalence point, it's going to be just your acetate ions. And then as soon as you're past this point, while there is acetate and hydroxide present, only hydroxide is really going to affect the pH because hydroxide is a strong base. Okay, so being able to recognize what's present during each part of this curve is really crucial. Then, what if I also said, okay, instead of a weak acid, strong base, how would this curve look different if I had a strong acid and a strong base? Well, if I have H+, because it's a strong acid now, not a weak acid, and hydroxide, that would produce just water. Okay, so how is this curve going to look different? Well, because it's a strong acid, if I start with just a strong acid, the initial pH is going to be lower simply because all of the hydrogen ions are going to dissociate. Okay, then I'm going to draw my curve. Okay, and then after this point, it's going to look just like the other curve, okay? So my equivalence point is going to be here. Sorry, they should be at the same volume, and that's an important note. But ways that they're different, your initial pH is going to be lower. Your pH at your equivalence point is going to be lower. But notice something that some people had some issues with. The volume of hydroxide that's required to reach equivalence point with a strong acid and a weak acid is the same. Okay, so whenever we do the stoichiometry, it always requires the same volume of base. It doesn't matter if it's strong or weak, it requires the same amount. What's different is the pH. So the initial pH and the pH at your equivalence point will be different. Okay, so if I were to ask you, okay, well, what's present during this curve? Okay, keep in mind, I start off here with just H+. So I have just H+ here. Okay. I add hydroxide, but the only thing that's going to be present is still some hydrogen ions throughout, just like it was with your weak acid. But your conjugate here, because you're dealing with a strong acid and a strong base, it's just going to have water. Okay, because we're going to ignore the sodium and the chloride. Like, for example, if I had hydrochloric acid and sodium hydroxide. At my equivalence point, the only thing that's going to be present is water, because I have equal amounts of hydrogen ions and hydroxide ions. So that's why the pH of a strong acid and a strong base at their equivalence point is 7. As soon as I continue to add hydroxide past the equivalence point, now I'm just adding OH-. And that's why the pH skyrockets, because I'm just adding a strong base. Now let's draw the titration curve for a weak base and a strong acid. So let's say, for example, my weak base, let's use the example that was given in the practice. So you have NH3 as my weak base. If it's a strong acid, it's just H+. So that would produce NH4+. Okay, so I've got my graph. I've got pH on the y-axis, and then since my titrant this time is going to be hydrogen ions, it's going to be volume of hydrogen ions on your x-axis. So if I were to draw this, my curve would look something like this. Okay, a couple of important features. At the very beginning, right here, the only thing that is present is NH3. Okay, then as I add hydrogen ions, I'm going to start producing ammonium. At my equivalence point, okay, I'm going to have, since I have equal amounts of NH3 and H+, the only thing that's going to be present is NH4+. Okay, which means at my half equivalence point, I've got equal amounts of NH3 and NH4+. Okay, which means past my equivalence point, the only things that are going to be present are still NH4+, that's going to stay the same. Okay, and now that I'm adding excess of it, I'm going to have hydrogen ions. So if the question is what species is affecting the pH at each location, well, starting here, I have NH3. Okay, so that's what's affecting my pH. Then along here, I have NH3 and NH4, which are both affecting my pH. As soon as I reach my equivalence point, I only have NH4+ affecting it. Notice since NH4+ is a weak acid, my pH is going to be less than 7. Okay, and we know that because we have a weak base and a strong acid. Then past that point, you'll have NH4+ and H+ present, so H+ is going to be what's affecting your pH. Okay, what if instead I wanted to react a strong base with a strong acid? Well, I would have OH- and hydrogen ions producing water. Okay, so since I start off with just a strong base, its initial pH is going to be higher because strong base will dissociate completely, a weak base will not, so you're going to have more hydroxide ions here. Okay, so when I'm drawing this, it's going to look more like this. Okay, and then it'll start to look like the other graph. Okay, so I'm going to put my equivalence point here. At the very beginning, what I have is just hydroxide. That's why its pH is so high. Then I start adding hydrogen ions. At my equivalence point, I have only water, okay, which means at my half equivalence point, okay, because I have a strong base and a strong acid, well, what do I have? I have half hydroxide, half water. That's why its pH is still so high. Okay, so I've got hydroxide and water there. Past my equivalence point where I just have water, then the only thing that's going to be left over is water and hydrogen ions. Okay, so what's affecting the pH? Well, up until your equivalence point, it's really your hydroxide ions that are affecting your pH. At your equivalence point, you know you're at 7 because you only have water. Remember, we're assuming we're at 25 degrees Celsius. And then past your equivalence point, you only have hydrogen ions.